We're not exactly sure what contribution the nutrients from the birds make to the reef. We suspect it's pretty high, and most studies to date have really just focused on that shallow flow, and yet we're interested in what's coming out on the side of the reef. My name's Dirk Erler. I'm from Southern Cross University. I'm a research scientist. I work on groundwater and nutrient cycling. The Leaf to Reef program is all about understanding how changes on the terrestrial side of things affect the marine side of things. And for me, the big link is groundwater, because that carries nutrients from the land into the marine environment. Part of my work here is looking at the connectivity between the terrestrial side of things and also the reef. So I'm looking for nutrients that are coming from the birds through groundwater, and then that gets discharged into the reef environment. And the nutrient that's discharged to the reef environment carries a fingerprint or a signature that comes from the bird poo. So we can trace bird poo into the marine system. And on this particular trip, I'm looking to see how far out from the island that signal of bird poo propagates. So we know that it is discharged to the nearshore environment, so that's the stuff growing just off the beach. But further out, we don't really know how far that nutrient travels, so that's the objective of the next few days here. So we've got groundwater that sits under the surface at about 3 metres, and what happens is when the birds, all the bird guano gets dropped, and then with rainfall it percolates down into the groundwater table, and it's got a lot of nutrient in it. So the first thing we do is we have a series of what are called piezometers. They're basically groundwater sampling stations around the island, and every time I come here I take groundwater samples. This thing here just measures moisture. When it hits water, it beeps. So then, and this has just got some marks on it, so we can measure how deep the water is. .03. This thing here is just a groundwater pump, so we're going to pump out some of this water and then start to collect it. So I'm measuring dissolved oxygen, temperature, conductivity, which is salinity. So salinity is important because we want to know how much salt is getting into this aquifer. So the salinity is about 3.5 salinity units, and the ocean water is about 35. So it's quite fresh, but it's just got that tinge of salt to it. But this is one of the fresher parts of the island because we're so close to the middle. And I do that in the high and the low tide, because in the high tide the water table lifts, and that pumping action is actually what sucks the groundwater out. So the seawater comes in and mixes with it, and it pulls some of that nutrient out. So that's the main way in which we get groundwater running out. It's not from rainfall, it's from that what we call tidal pumping. Freshwater enters the island through recharge, which is basically rainfall, but we also have water going upwards as well through what's called evapotranspiration, which is trees basically releasing water to the atmosphere. Now, some of that fresh water that does make it into the ground goes deep within the island and comes out on the edge of the reef, and some of it hits this thing called a reef plate, which is basically a large calcium carbonate structure that goes through the island, and it flows over the top of that into the shallow section. So we have a shallow flow and a deeper flow, and most studies to date have really just focused on that shallow flow, and yet we're interested in what's coming out on the side of the reef out into the open ocean. The strategy we use is, in this particular trip, we're going to go out into offshore area, and we're going to take a series of samples at increasing distance from the island. So I don't know how long that distance will be. Maybe 100 metres is enough to capture enough plankton?
More than enough.
Yeah, so while these guys are diving, we'll do at least 1 or 2 of these. Oh yeah, so we've got 12 to do. So at each site we'll collect take a net sample of zooplankton, we'll measure the total volume, and then I'll take a subsample of that and you can have the rest.
Today we're going to head out on the boat, and we're actually going to circumnavigate the whole island to collect zooplankton samples from the water, as well as do some really shallow water diving along the reef to collect small coral nubbins and some sand so that we can trace those nutrients from offshore into shore around the island.
So nitrogen exists in a range of different forms, and we try and measure as many of those as possible. So inorganic nutrients, things like fertilizers, nitrogen fertilizers, for instance ammonium and nitrate, we'll measure that dissolved in the water. We'll also measure organic nitrogen, which are the larger molecules that are produced by organisms. And also we'll measure particulates, so that's the solid bits in the water column, and that can include anything from zooplankton to phytoplankton to what we call detritus, which is basically any dead organic matter that's floating around. We tow a net to catch the particulates, and then we basically concentrate that into a sample. And we also collect large volumes of water, which I'll bring back to the lab and filter through very fine meshes and capture the particulates on that. So we get basically different sizes of particulate. We've got a submersible pump over the side, and from that pump we'll then feed water up here. We'll collect them in the barrels, and we're just looking for phytoplankton. What we're ultimately trying to understand is how changes in management, what happens if you clear an area, what happens if you vegetate an area. That obviously has impacts on the visitation of birds, which then leads on to the amount of nutrient that's put into the ground and then into the groundwater, and how much nutrient then gets out to the reef. So those changes on land have huge implications for what's happening in the marine system, but we just don't know what those implications are or how big they are.